Hello everyone, welcome to today's video. So, in today's video, we will see modular arithmetic and we will see only a little part of it, I would say. Just enough to let us solve problems that come in JEE Mains or Advanced. And we will see it in a much more detail in an upcoming video when we will be studying for the entrance of ISI, BStat and same IBSC exams and also a bit for RMO, INMO actually. So, anyway, this is something that will help you find reminders in a way you may not have seen before. If you know already what this means, you are already going to know modular arithmetic is such a powerful tool and it's extensively used in number theory. And if you're only finding reminders up till now using binomial theorem, so this is going to be an upgrade for you. So understand that A congruent to B mod M, this notation where this triple sign is called a congruent to. This means that M divides B minus A. Or in other words, if A is congruent to B or B is congruent to A, it's written like that, and in brackets you have mod M, this would mean that M will divide B minus A and vice versa as well. An example would be 5 is congruent to 2 mod 3 and 2 is congruent to 5 mod 3. Both are true because you see 3 divides 5 minus 2, which is 3, or 2 minus 5, which is minus 3. Also, the properties of mod are as follows. Basically, if you have A congruent to B model, you can add or subtract something or multiply something from both sides basically. And there is another very interesting property. It's called exponentiation. You can exponentiate both sides to any positive integral power. Along with these tools, we can find remainders. And what is the remainder? So usually when you are asked that, okay, find the remainder when x is divided by y. So the divisor basically is the mod, and what you are finding the remainder of is basically the A and B is your answer. This is the form we would like to express this in. Okay. Along with this, we will also learn one more theorem, which is Fermat's little theorem, that if P is a prime and P does not divide A, so basically A is not a multiple of P and A is a natural number as well, then A to the power P, when divided by P, leaves the remainder of A. Or simplified, a to the power p minus 1 leaves a remainder of 1 when divided by p. So if a is a number which is not divisible by p, then a to the power p minus 1 when divided by p leaves a remainder of 1. Okay, let's take an example, right? That would clear up things. So we'll take two examples. The first one would be a little basic, and the second one would be something that has already came in JE. Okay. So remainder when 8 to the power 103 is divided by 13. Now, notice here step by step. First of all, 13 is a prime number, correct? Whenever you have prime numbers, you can apply Fermat's little theorem. So that means applying Fermat's little theorem, or FLT in short, do not confuse it with Fermat's last theorem, which is different. You can say a to the power p minus 1 is congruent to 1 mod p, right? Where a is your 8, which is not divisible by 13, of course. P is your 13. This means 8 to the power 12 is congruent to 1 mod 13. Now, the approach is you need to go as near as possible to 8 to the power 103. How can you do it? You can do it using exponentiation. You notice that there is a 1 on the other side. That means whatever we exponentiate it will not change because 1 to the power anything will be 1 itself. So we do 8 to the power 12 whole to the power 8 on both sides, which gives us 8 to the power 96. And that is also again still 1 mod 13. Multiply 8 to the power 7 because multiplying that would give you 8 to the power 103 on both sides. So this would mean that our actual answer 8 to the power 103 is nothing but 8 to the power 7 mod 13. So if you can just find 8 to the power 7 mod 13, that would be your answer. Again, notice very simply that 8 square is 64, 64 is 65 minus 1, and 65 is nothing but 13 into 5 minus 1, which means dividing 8 square by 13 should leave you a remainder of minus 1. Yes, you can also express it like it leaves a remainder of 12. But in modular arithmetic, you can also use negative numbers as remainders. So remainder of 12 would also mean a remainder of minus 1 as well, because this helps you in calculations, which is the fantastic part of this, right? So thus, now let us do the calculation 8 to the power 103, which can be written like this, which, as we have proved, is congruent to this from this step. And again, 8 to the power 7 can be written as 8 to the power 6 into 8, where 8 to the power 6 is 8 square whole cube. And you see how everything can be plugged inside the modular sign, right? So 8 square is minus 1 mod 13. So 8 square whole cube would be minus 1 whole cube because you can exponentiate and multiply 8 to get this. So the answer is minus 8 mod 13. Again, you want the answer in positive terms. So going from positive to negative or negative to positive in remainders is very easy. You either have to add 13 or subtract 13, and the modulus will not change, and the modular value, the remainder will not change. Therefore, if you add 13, you simply get 5, which is the positive integral remainder. So 8 to the power 103 is congruent to 5 mod 13. Okay. Okay. Let's see another problem which came in JE. We will apply the same kind of methods. So 2021 to the power 3762 when divided by 70. So 2021, first of all, we need to note that this is congruent to 15 mod 17. So if you divide 2021 by 17, it gives you 15, which again is minus 2 mod 17, right? It's 2 less because 15 is not easier to work with when exponentiating, but 2 is, which is why we are writing this. Therefore, exponentiating both sides with 3762 will get this. Now, using FLT on 2 and 17 again, you get 2 to the power 17 minus 1, which is 16. And now we need to go as close as 3762 as possible. You will see that 235 is the closest multiple, which produces 3760. And we exponentiate that on both sides. So therefore, 2 to the power 3760 is 1 mod 70. And you are done with the answer because if you multiply 2 square on both sides, you will simply get this thing is congruent to 4 mod 17. And this thing itself was congruent to the actual answer, which means the actual answer leaves a remainder of 4 on dividing by 17. You see how easy this is to use this modular arithmetic techniques to find out remainders. So I will also start posting some crash course for JEE Main 2025 January attempt for all the chapters one by one now on YouTube. So let me know how you like this video. This would be a very useful tool for you to find out remainders in very less time as compared to before. Thank you for watching. If you're new to the channel, please do subscribe.